Welcome back, everybody. We're on our third Chapter 10 review video. 2 down, 2 to go. In this one, 10.3, we're talking about areas of regular polygons. Let's get going with that. Alright, so jumping right into that here. Problem 1, what's the area of the regular octagon? Reminder, when we say regular polygon, we're just talking about polygons or shapes that are nice looking, I guess we'll say. Okay, regular octagon in this case, when we say regular, we know that all the sides have the same length, all the angles have the same measure. And if we have a regular octagon, our area formula is just equal to 1/2 times little a, standing for the apothem, times p, which stands for the perimeter of the figure, in other words, the sum of the sides. I'm going to say this is the easy one for the day, where I have both my apothem and the side length to calculate the area. We'll just plug things in. Area is equal to 1/2 times the apothem, 14.5, times the perimeter, so as in side lengths of 12, times there are 8 of them for the octagon. All right, if we plug that in our calculator, I end up with a 696, we could say, centimeters squared. Okay, pretty simple equation to use. As far as where it's coming from here, if I look at the 1/2 times 14.5 times 12, that's basically giving me the area of one triangle, one of the triangles that makes up this octagon. And then by multiplying that by 8, that's going to give me the other 8 triangles that make the whole thing up. Okay. Now the trick is we want to also be able to use this formula when I don't have all the pieces of information. That's what we're going to work towards with the rest of this video. Okay, kind of putting the solving parts together to find areas of regular polygons as well. In the next question, we're going to look at finding angles within regular polygons. Okay, why would I want to do that? Well, if I need to solve for, let's say, an apothem, okay, or a side length, to use the triangles, it'd be nice to know what these different angles are here. Okay, so let's go ahead and do that. Let's start off with angle 1. And for angle 1, what I'm going to do is I'm going to take 360 degrees, which is going to be the sum of all these central angles here. Okay, all these angles that come together at the center would add to 360 because they make a full circle. I'm going to divide that by the number of angles I have, in other words, the number of sides I have. Okay, let's count this guy. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So dodecagon, I think. 360 divided by 12. When I do that, I end up with 30 degrees. Okay, so angle 1 equals 30. And then to get angle 2 next, now I know that angle 2 is formed by one of these radii, we could call it, and the apothem. So in other words, what we're doing is we're taking this angle measure of 30 right here and splitting in half. So angle 2 is just going to be the 30 degrees we just found divided by 2. In other words, 15 degrees. And again, the point of this, once I have that angle 2, I have an angle in a right triangle that I can use to solve for the apothem, which we'll do in a minute here. Next up, we could also find a different angle in that triangle, angle 3. Now I have a right triangle. I know that one of the angles is 15, the other will be 90. So for angle 3, what we can do is say 180 for the total sum of the measure of a triangle, minus 15 degrees, minus 90. And that's going to give us a 75 degrees. All right, so that's how we can find angle measures in regular polygons. Next thing we're going to do is combine some trigonometry with solving for areas. Okay, use trig to solve for missing parts. Now, problem 3 here isn't a regular polygon, it's just a triangle. But it's the same kind of approach we're going to take to a regular polygon in a minute. So it's good trig practice as well. All right, what's the area of the triangle? We know area of a triangle is equal to 1/2 times base times height. Okay, so it's good to review with that formula as well. Now, problem here is I have two of the bases of the triangle. Any side of a triangle can be the base. I don't know either height. I don't know the distance from either base to the opposite vertex. Okay, so that's what we need to solve for with this one. To do that, so what I want to know is this height at a right angle. And with that height, we'll call that h. I'm going to split this triangle up into a right triangle. I suppose two right triangles. Now on the left side here, I have a right triangle where I know an angle and I know a side length. Okay, anytime you know an angle and a side, you can use trigonometry to solve for the other side, or either of the other two sides. As far as what I have here, the h is the opposite side to that 42. And if this is my right angle, that means that 10 is the hypotenuse. As far as which trig ratio to use, opposite hypotenuse, that's my sine ratio. A reminder, that's on your formula sheet. Hopefully you're following along with that here. Okay, we know that the sine of an angle is equal to the opposite length over the hypotenuse length. All right, filling in what we know, we've got 42 degrees. We could say that sine of 42 for my angle is equal to opposite. We don't know that's the h over hypotenuse, which is the 10. And then to finish this off, I'm going to multiply both sides of this equation by 10 to get the h by itself. H's alone, I'll plug in the 10 sine 42. And when I do that, I end up with a, I'm going to say 6.691. Okay, that's my height. Now with that height is an intermediate answer. Okay, it's an answer we're going to use to find another answer. So I'm going to leave that rounded to 3 decimal places because that's going to make my final answer as accurate as possible. Okay, back to my area formula then. Area is equal to 1/2 times the base. Now we need to use the base we just found the height for, so we need to use this 16. We can't use the 10. All right, times the 6.691 we just found. And when I multiply all that through, I end up with a 53.5, we'll say, inches squared. And I'm just going to round that to a single decimal place. Intermediate answers to 3 decimal places. Final answers will just go to 1 decimal place. And again, if I didn't round this to 3 decimal places, I would be off with this final answer. Okay, it wouldn't round the same way. Okay, mainly that's a trick for Math Excel to make sure you're not losing points just for rounding. All right, last problem. Let's put all that together. Let's solve for the area of a regular polygon where I don't have all the pieces. In this case, I know the side length. What I'm missing is the apothem. Okay, distance from center to side at a right angle. Okay, to figure that out, what I need to do is make a right triangle where I have a side length of the apothem we don't know. And this chunk is just going to be half of the side length we're given, half of 14, which would be a 7. And now before I can do anything with this triangle, before I can solve for any side lengths, I need an angle. So to get this angle, what I'm going to do is I'm going to make a larger triangle. Okay, that's made up of an entire side length. And to get that central angle, we'll go 360 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. Which will give us 40 degrees. Okay, so I have 40 here. All right, once I know that 40, I can split it in half. And I'm just going to redraw this triangle here quick so we can see it a little bit better. So I have a right triangle with the apothem I'm solving for, side length is 7, and 40 over 2 I suppose is 20. So an angle in the top of 20 degrees. Again, we can use trig to solve for my missing apothem. Okay, across from the 20 is the opposite side. Next to the 20 is the adjacent side. Opposite adjacent, that's my tangent ratio. We know that tangent of A is equal to the opposite over the adjacent. All right, filling in what we know, the angle is 20, so we can say tangent 20 is equal to the opposite 7 over the adjacent A. And then I need to solve this equation for my A. I'm going to multiply both sides by the denominator, the A, to clear out the fraction. So now I have A times tan 20 is equal to 7. And then to get the A by itself, I'm going to divide both sides by tan 20. And we end up with A equals 7 over tan 20. Okay, the variable's by itself. Now I'll plug it into the calculator. And when I do that, I get A 19.232. Okay, again, I'll round that to 3 decimal places because we're talking intermediate answer. That was the hard part of the question. And I suppose good trig review. Now let's actually solve it and find the area. Area of a regular polygon is equal to 1/2 times the apothem we just solved for, that 19.232. Okay, times the perimeter, which would be 14 for the side length, times the 9 sides. And when I plug all that in, I end up with a grand total of 1,211.6 centimeters squared, we could say. All right, there's a review of 10-3. You can now move on to that Math Excel assignment. The next 4 would put you at 9 through 12. Remember, if you're keeping up here, if you're taking care of one of these videos a day this week and getting through the 4 corresponding homework questions, okay, that's going to get you done by Thursday, which will allow you to take the quiz on Friday and be ready for the quiz, and then you're good to go for the week and good to go for spring break. Okay, give the Math Excel a shot, and like we said, if you need any help, if you get stuck with anything, let me know. We'll help you out.